Hello everyone, today we are going to learn about hidden layers. So what is a hidden layer? A hidden layer in a neural network is an integral part of the network architecture that lies between the input and the output layers. And hidden layers are the intermediate layers that process the input data through various transformations. Each hidden layer consists of neurons and receives input from the previous layer, processes it, and passes the output to the next layer. So why do we need a hidden layer? The first reason is feature extraction. Hidden layers transform the input into features that can be useful for particular tasks. For instance, in image recognition, early hidden layers might detect edges, while deeper layers may detect complex patterns like faces. The second reason can be nonlinearity. So hidden layers introduce nonlinearity into the network through activation functions which allow the network to model complex relationships between inputs and outputs. The third reason is learning representation. So the hidden layers enable the network to learn hierarchical representations of data with each layer capturing more abstract features. The next reason is dimensionality reduction. Hidden layers can help in reducing dimensionality by compressing information while keeping essential features. It allows the representation of the data in a lower dimensional space, making it easier to visualize and interpret complex data. And the last reason is enhancing flexibility and performance. Because of hidden layers, more layers and neurons provide greater flexibility in adjusting the parameters during training, allowing the network to better fit the data. Also, deep networks with multiple hidden layers perform exceptionally well in various tasks, including image recognition and natural language processing. However, there is no universal rule for determining the optimal number of hidden layers. It requires experimentation and depends on the complexity of the task and the dataset. So now let's move on to the first exercise. In this exercise, we have two input samples, x1 and x2, and one row of weights and biases here. So these x1 will get multiplied by this weight here. So 3 into 1 plus this one into this one. So 1 into 1. So 3 plus 1 will give us 4, and there is no bias value here. So we will get 4 as the intermediate value. And then going through the ReLU function, we know that if we get a positive number in ReLU function, we will get the number as it is. But if it gets a negative number, the ReLU function will return 0. So from this 4, we will also get 4 here. So this value of this hidden layer 4 will get multiplied by this weight here, which is 1. Then 4 into 1 will give us 4. And then the bias is -1. So 4 minus 1 will give us 3. And passing through the ReLU function, we will get the final output as 3. So now let's fill in the diagram here. So x1 is 3 here and x2 is 1 here. So these two inputs will get multiplied by these two weights, which is 1 and 1. So 1 and 1. And then by adding the bias, we will get 4. And the final output of the hidden layer will be 4 here. So this 4 will get multiplied by this one here. So 1. And then adding the bias, we will get the final output from the ReLU function y is equal to 3. Now let's move on to the next exercise. So x1 and x2 will get multiplied by these two values. So 1 into 1 plus 2 into -1. So 1 minus 2 will give us -1. And then adding the bias, we will get here -1. Passing through the ReLU function, the output of this hidden layer will give us 0. So then next, this 0 will get multiplied by this 2. So 0 into 2, 0. Then this is the bias. So 0 minus 1 will give us -1. And passing through the ReLU function, we will get the final output as 0. So let's fill up this diagram again. So x1 will be 1, x2 will be -1. These x1 and x2 will get multiplied by these weights, which is 1 and 2. So x1 will get multiplied by 1, x2 will get multiplied by 2. And then the value of the hidden layer is 0. So we will get 0 here. This 0 will get multiplied by this 2 here. And the final output will be y is equal to 0. Now the next exercise. So 3 into -1 will give us -3. Then 1 into 2 will give us 2. So -3 plus 2 will give us -1. So -1 and then adding the bias plus 1, which will give us 0. So going through the ReLU function, this 0 will again be 0. So now what happens is that we have one row of weights and biases for the first set. Now we have two rows of weights and biases for the second set. So this value of the hidden layer will get multiplied by this row first. So 0 into 2 will give us 0, and then adding the bias will give us 1. So 1, and passing through the ReLU function, y1 will be 1. Then this 0 will again get multiplied by this 1. So 0 into 1, 0, plus the bias, which is 2. So the intermediate value will be 2, and passing through the ReLU function, we will get 2. So if we try to fill up the diagram here, x1 is 3, x2 is 1. So these 3 and 1 will get multiplied by -1 and 2 respectively. And the value of the hidden layer will be 0. So this 0 will now get multiplied by 2 for the first output, which is y1. And then again, this 0 will get multiplied by this 1 for y2. So we will get here 1. And y1 is 1 and y2 is 2. Now the next exercise, 3 into 1 plus 1 into -1 will give us 2, and then 2 plus 0 will give us 2. So passing through the ReLU function, the output of the hidden layer will be 2. So these 2 will get multiplied by this row of weight and bias for y1. So 2 into 1, 2, -1 will give us 1. So passing through the ReLU function, we will get 1 here. And for the second row of weight and biases, these 2 will get multiplied by this one. So 2 into -1, -2 plus 1 will give us -1. And passing through the ReLU function, we will get 0. So x1 is 3, x2 is 1. This 3 will get multiplied by this one. So 1 here. This one will get multiplied by -1 here. So here it will be -1. And then the output of the hidden layer will be 2. So this 2 will get multiplied by this one first. So 1 here. And then with this -1 for the second connection, or y2. So we will get -1. And the output of y1 is 1. Then the output of y2 is 0. So we will put 0 here. Now exercise 5. So we have 2 rows of weights and biases for the first set and 2 rows of weights and biases for the second set also. So this is getting a bit more complex now. So these input samples will get multiplied by the first row. So 2 into 2, 4, plus 3 into -1 will give us -3. So 4 minus 3 will give us 1. So 1 plus the bias will give us 2. And ReLU will give us the first value, which is h1, and it will be 2. Then for this row, 2 will be multiplied by 1. So 2 into 1, 2. Then 3 into 1, 3, 5. -2 will give us 3, and ReLU will return the second value, which is h2. It will be 3. So these h1 and h2 will get multiplied by this set of weights and biases now. So 2 into 1, 2, plus this 3 into 1. So 3, 5. 5 plus 0 will give us 5, and we will get the final output as 5 also. And then these 2 will get multiplied by this 0. So 2 into 0, 0, plus this 3 into 1, 3. So 0 plus 3 will give us 3. Then 3 minus 1 will give us 2. So the output of y2 will be 2. So now let's fill in the diagram again. x1 is 2 and x2 is 3. Now these 2 will be multiplied by 2 in case of h1. So we will write 2 here and then 1 in case of h2. So weight for this connection will be 1. And then for this 3 will be multiplied by -1 for h1. So -1. And then 3 will be multiplied by this 1 for in case of h2. So we will write here 1. So h1 is 2 and h2 is 3. Now, in case of h1, these 2 will get multiplied by 1 for y1. So for y1, we will get the weight as 1. And for y2, this h1 will get multiplied by 0. So we will write 0 here. And then for h2, it will be getting multiplied by 1 in case of y1. So this will be 1. And then h2 will get multiplied by this 1 for y2. So this will be also 1. And y1 and y2 will be 5 and 2 respectively. Now, exercise 6. So for this particular value, we have to multiply this row and this column. So these 2 will get multiplied by 2. So 2 into 2, 4, plus 3 into -1, -3. So 4 minus 3 will return us 1 here. And passing through the ReLU function, this 1 will return us also 1 here. So now these two values of H1 and H2 will get multiplied by this set of weights and biases, and 1 will get multiplied by 1. So 1 into 1 plus 1 into 1 will give us 2. So we will get 2, and passing through the ReLU function will give us 2. But the second value, 1 into minus 1 plus 1 into 1 plus 1. So minus 1 plus 1 will give us 0, and we will get 0 here. So let's fill up the diagram again. So x1 and x2 will be 2 and 3. In case of x1, it will get multiplied by minus 1 and 2. So the first connection's weight is minus 1, and the connection of x1 to h2, the weight will be 2. And then from x2 to h1, the weight will be 1. So this will be 1. And then from x2 to h2, this weight will be minus 1. So we will get minus 1 here. And then h1 is 1. h2 is also 1. So in case of h1, it will get multiplied by this 1 and this minus 1. So the first connection's weight value will be 1. And then from h1 to y2, we will get minus 1. And then for h2, this value, it will get multiplied by this one first, then this one. So we will get weight values for this connection 1 and also for this connection 1. And the final value of y1 and y2 will be 2 and 0. Next exercise, now we have one more row of weights and biases for the first set. So these x1 and x2 will get multiplied by these rows of weights and biases. So 3 into 0, 0 plus 1 into 2, 2. So 0 plus 2 will give us 2, and then plus 1 will give us 3. So the output here will be 3. Passing through the ReLU function, we will get also 3 here. So we are going to multiply these two values again with this row of weights and biases, and we will get the final output as 3. Following the same logic. For this row, we will get 3 into 1, 3 plus 0 into 1, 0. So 3 plus 0 will give us 3, then minus 1, which will give us 2. So the final output from the ReLU will be 2. Now, these three values will be getting multiplied with these two rows of weights and biases for the second set. For instance, these 3 will getting multiplied by 1. So 3 into 1, 3 plus 3 into 1, 3. So 3 plus 3 will give us 6. So 6 plus 0, then the bias is 0. So 6 plus 0 will give us 6, and passing through the ReLU function, the final output will be 6. And then for the second row, these three values will be getting multiplied by this second row. So 3 into 0, 0 plus 3 into 1, 3 plus 2 into 1, 2. So 3 plus 2 will give us 5, then minus 1, which is 4. And passing through the ReLU function, we will get 4. Now let's fill up the diagram. x1 and x2 is 3 and 1. So for x1, it is getting multiplied by these three values for h1, h2, and h3. So from x1 to h1, the weight value will be 0. Then x1 to h2, the value will be 1. Then x1 to h3, the value will be 1 again. In case of this x2, it will be getting multiplied by these three values. So x2 to h1, we will get 2. x2 to h2, we will get 1. And x2 to h3, we will get 0. So the values of the hidden layer h1, h2, h3 will be 3, 3, and 2. So now for this h1 will get multiplied by these two values in case of y1 and y2. So for h1, the first connection from h1 to y1 will be 1. The second connection h1 to y2 will be 0. Then for h2, it will be this one from h2 to y1 and this one from h2 to y2. And at last, for this h3, for y1, we will get this 0. So h3 to y1, we will get 0. And h3 to y2, we will get 1. And the final value of y1 and y2 will be 6 and 4. Next exercise, for this particular value, we have to multiply these input values with this row. So 3 into minus 1 minus 3 plus 1 into 1. So minus 2 plus 0 will give us minus 2. And then passing through the ReLU function, we will get 0 here. So following the similar logic as the previous example, we will fill up these values. So simply this value of the H2 will be 0 here. And you can fill up the diagram following the previous example. Now, for this particular value, we have to multiply these two values with these rows. So 2 into 1, 2 plus 1 into 1, 1. So 2 plus 1 will give us 3. So 3 minus 1 will give us 2. So 2, and then passing through the ReLU function, this 2 will give us also 2. You can fill up these values as the previous example. So this H3 will be 2. Now let's just fill up the connections for H3. So for H3, we have two connections from X1 to H3 and from X2 to H3. So for H3, we have to look on this. So for X1, the weight value will be 1. So from X1 to H3, we can write 1. And from this X2 to H3, we can write this one. So also 1 here. And then from H3 to Y1 and Y2, so this H3 to Y1, this H3 will be getting multiplied by this one. So from H3 to Y1, we will get -1. And from H3 to Y2, we will get this +1. So +1. You can fill up the rest of the values as the previous example. Next exercise, we have to find out these values. So for finding out these values, these three values of H1, H2, and H3 will be getting multiplied by this row of weights and biases. So 5 into 1, 5, plus 0 into 0, 0, plus 3 into -1, -3. So 5 minus 3 will give us 2. And then 2 minus 1 will give us 1. And passing through the ReLU function, we will get the final output as 1. Now let's fill up the connections for this Y1. So Y1 is connected to H1, H2, and H3. So H1 will be 5, H2 is 0, and H3 is 3. So for Y1, the weight values are these. So from H1 to Y1, we get the weight value as 1. So we will write 1 for H1 to Y1. And then from H2 to Y1, we will get the weight value as 0. So we will write H2 to Y1 weight value as 0. And then from H3 to Y1, we will get the weight value as -1. So H3 to Y1, the weight value will be -1. And finally, Y1 will be 1. Now, next exercise, we have to fill up this value. So these three values of X1 and X2 and X3 will get multiplied by this row of weights and biases. So 3 into 0, 0, then 1 into 1, 1, plus 2 into 1, 2. So 3, then 3 minus 1 will give us 2, and passing through the ReLU function, we will get 2 also. So these three values will be getting multiplied by these two rows of weights and biases in this case. Now, this example has become a bit more complex as we have 3 inputs now and 3 columns of weights. So let's look and try to break down what is happening here. So X1 is getting multiplied by this value for H1. So X1 to H1, we will get 0. Then X1 to H2, we will get 0 again. So X1 to H2, his value will be 0. And then again, X1 to H3, we will get 1 here. Then for X2, this X2 will be multiplied by this one as the weight value for H1. So X2 to H1, we will get 1 here. Then X2 to H2, we will get 1 here again. Then X2 to H3 will give us 0. Now, X3 to H1, we will get 1. X3 to H2 will give us 0. Then X3 to H3 will give us 2. So these are the values of the weights here. Then H1 is 2, H2 is 0, and H3 is 6. You can fill up the rest of the connections as the previous examples. Now, next exercise, we have to fill up these values. So for this value, we have to multiply these 3 input values with this row. So 2 into -1, -2, plus 1 into -1, -1. So -2 minus 1 will give us -3. Then -3 plus 0 will give us -3. So here it will be -3. And this -3 will pass through the ReLU function, and the final output will be 0 here. So let's fill up the connections for this H2. The value of H2 is 0. From X1 to H2, the weight value is -1. So -1. Then from X2 to H2, the connection value or the weight value will be -1. So this will be -1. And then from X3 to H2, the weight value will be 0. Now from H2 to Y1, this H2 will be multiplied by 2. So H2 to Y1 will be 2. And from H2 to Y2, H2 will be multiplied by 1. So H2 to Y2 will be 1. You can fill up the rest of the values as the previous example. Next exercise, we have to fill up this value. So we have to multiply these inputs with this row. So 1 into 0 plus 2 into -1 -2 plus 3 into 1, 3 will give us +1. So +1, and the final output from the ReLU function will be 1 also. So 1. Now let's fill up the values for H3. So H3 will be 1. And then from x1 to h3, we will get 0 as the weight value. So 0. Then x2 to h3, we will get -1. And then x3 to h3 will give us +1. So +1. And then from h3 to y1 and y2, we will get 0 and -1 respectively. Next exercise, we have to fill up these value. So h1, h2, and h3 will be multiplied by this row. So 1 into 0, 1 plus 6 into 1, 6 plus minus 1 into 2 minus 2 will give us 4. And from the ReLU function, we will also get 4 here. So let's fill up the connections from all the hidden layer values to y2. So h1 to y2 will be 0. Then h2 to y2 will be 1. And then h3 to y2 will be -1. So next exercise. So now we have 3 rows of weights and biases for the second set. So for this value, these 3 inputs will be getting multiplied by this row. So 1 into 0 plus 0 into 1 plus 2 into -1 will give us -2. So -2 minus 1 will give us -3, and passing through the ReLU function, we will get 0 here. So this value of h1 will be 0. So this portion is similar to the previous example, so we are not working on that. Let's fill up the lower portion. So from h1 to y1, the connection value will be 1 here. Then from h1 to y2, the value will be 0 here. And then h1 to y3 will give us 1. Now from this h2, so h2 to y1 will be 1 here. And then h2 to y2 will be -1. And then h2 to y3 will be 1. And now this h3 to y1 will give us 0. Then h3 to y2 will give us 0. And then h3 to y3 will give us 1. You can have a query like the weight value from h3 to y2 is this 0. So why are we drawing a connection here? So this diagram is quite general. It was not drawn based on the weight values. So this is the general diagram, and we are trying to fill up the values here. Next example, we have to fill up this value. So for this h3, this will be multiplied by this. So 1 into 0 plus 1 into 0 plus 2 into 0, all will be 0, and then -1 will give us -1. Passing through the ReLU function, we will get 0 here. So this h3 will be 0. So let's fill up the connections. So h3 to y1 will give us the weight value as 0. Then this h3 to y2 will be 0 again. And then this h3 to y3 will be 1. Next exercise, one more value of hidden layer is added. So what is happening here? We are getting one more row of weights and biases here. So for this particular value, we have to multiply x1, x2, and x3 with this row. So 2 into 1, 2, plus 1 into 0, plus 3 into 1. So 2 plus 3 will give us 5, plus 0 will give us 5 here. So the final value of h3 will be 5. And now this is also changed because we have 4 rows. So now we have 4 column of weights here. So let's check the first output value, y1. So 4 into 1, 4, plus 3 into 1, 3, plus 5 into 0, 0, plus 0 into 1, 0. And then adding the bias will give us 7. And the ReLU will also return us 7. So let's fill up the values for the connection of h3 here. So this h3 is 5. So from x1 to h3, the weight value will be 1. So this connection will give us 1. Then x2 to h3 will give us 0. Then x3 to h3, this connection will give us 1. And then from h3 to y1 and y2, so h3 to y1 will be 0, and h3 to y2 will be this one. Next exercise, we are filling up these values. So 4 into 0, 0, plus 3 into 0, 0, plus 6 into 1, 6, minus 1 into 1, -1. So 6 minus 1 will give us 5. So 5 minus 2, we will get 3, and this 3 will pass through the ReLU function, and we'll get the final output as 3. So let's fill up the connection values for y2. So from h1 to y2, the weight value will be 0. You can simply cross the connection also. It means that the value of h1 doesn't affect y2. Then for h2 to y2, it is also 0. So 0. Then from h3 to y2, it is 1. And then from h4 to y2, it is -1. Now we only have one final output, just y. So for this value, these 3 inputs will be getting multiplied with this row. So 1 into 0, 0, plus -2 into 1, -2, plus 3 into 1, 3. So 3 minus 2 will give us 1. So 1 plus 0, which is the bias here, will give us 1. And from ReLU function, we will also get 1. So now these 4 values of H1, H2, and H3 and H4 will get multiplied by this row. So if you multiply, we will get 1 plus 4 plus 5, which is 10. And also adding this 0, we'll get 10 here. So from ReLU function, we will also get 10 here. So let's write the connection values for this H1. So H1 will be 1. And from X1 to H1, the weight value will be 0. Then X2 to H1 will give us 1. And then from X3 to H1 will also be 1. Now we have 2 inputs and 4 hidden values. So for this particular value, 3 into minus 1 minus 3 plus 1 into 0 0. So it's minus 3 plus 0, then the bias is also 0, so minus 3, and the ReLU will return us 0 from here. So these 4 values will be multiplied by these 4 values, and then we can get the final output as 6. So let's fill up the connections for H3. So H3 is 0, and from X1 to H3, we will get minus 1, and from X2 to H3, we will get 0. H3 will be getting multiplied by this one. So from H3 to Y will also be 1. Now again for this value, this will be multiplied by this one. So 0, and then 4 into 1, 4. Then 0 into minus 1, 0. Then 2 into minus 1, minus 2. So 4 minus 2 will give us 2. And then the final value of Y will also be 2. So let's fill up the connections for this connection Y. So Y is 2. So H1 to Y, we will get 1 as the weight value. So H1 to Y will be 1. H2 to Y will be 1 also. H3 to Y will be minus 1. And then H4 to Y will also be minus 1. Now for this value, these 2 input values will be multiplied by this row. So 2 into 1, 2 plus minus 1, 2 minus 1 will give us 1. Then 1 plus 2 will give us 3. So this 3 will pass through the ReLU function, and the final output of H5 will be 3. Now what happens is that these 5 hidden values will be getting multiplied by this row, and we will get the final output as Y is equal to 7. So let's fill up the connections for H5. So H5 is 3 here. So from X1 to H5, we will get 1. And then from X2 to H5, this connection value will also be 1. Now from H5 to Y, we will just simply get 1 as the weight value because H5 is getting multiplied by this way. So H5 to Y, we will get 1. And the final output of Y will be 7. Now this exercise, we have to find out this value. So these 5 hidden values will be getting multiplied by these 5 weights and 1 bias. So for this 0, we are not multiplying anything. So 3 into 1, we will get 3 plus 1 into minus 1. So 3 minus 1 will give us 2, then 1 into minus 1. 2 minus 1 will give us 1. And then adding the bias, 1 plus 1 will give us 2. So the ReLU function will return 2 also. Now the value of Y is 2. So how are we getting this 2? So from H1 to Y, we are getting the weight value as 1. Then from H2 to Y, we are getting the weight value as 1 again. H3 to Y, we will get 1. H4 to Y, we will get minus 1. And H5 to Y, we will also get minus 1. Now we have one more hidden value. So H1 to H6. We have to find out these values. So these inputs are going to be multiplied by this row. So 3 into 0 plus 2 into minus 1 will give us minus 2. So minus 2 plus 1 will give us minus 1. So ReLU function will return 0 from this minus 1. Now, if we multiply these 6 values with these 6 weights, we will get 8, and then the bias is 0. So 8 plus 0 will give us 8 also. Now let's fill up the connection values for this H5. So H5 is 0. From X1 to H5 will be 0, and then X2 to H5 will be minus 1. Now from H5 to Y, this H5 is getting multiplied by this one. So H5 to Y, the connection's weight value will be 1. Now the last exercise. 2 into 1, 2, plus 3 into 1, 3, 2 plus 3, 5. So this is not getting multiplied as one value is 0 here. Then again, 2 into 1, 2. So 5 plus 2 will give us 7. And then 1 into 1 plus 1 will be 8. And then adding the bias, we will get 8 here. So the ReLU function will also return 8. So let's fill up the connections for Y is equal to 8. So you can see from all these hidden values to get to Y, the connections weight values are all 1. So we can simply write H1 to Y 1, then H2, H3, H4, H5, H6 to Y, all are 1. So these are the weight values for these connections. So in this video, we have learned how the hidden layers work. So hidden layers are fundamental to the ability of neural networks to learn and generalize from data. They enable the construction of complex models capable of performing tasks ranging from image classification to language translation. I hope you found this video helpful. Thank you.